Welcome everybody, this is Evan Pennington with Trimble. We have an opportunity to look at a really neat project today that we partnered with the Cement Masons OPC MIA Local 404 in Cleveland, Ohio. This was an ADA compliance test for the apprentices in order to learn how to correctly pour ADA ramps in compliance with laws. So we had quite a few apprentices there. We had 4 different ramps that we were pouring, and we're going to take a peek at how laser scanning can actually improve your workflow, increase accuracy, reduce rework, and a few other items in today's lesson. So let's start off at the beginning. This is a 3D model of their shop made by Stephen Ostrowski from Trimble. So Stephen made this for the local 404 instructor, Barry DeJulius. They were also helped out by Ben Little with BuildingPoint Ohio Valley. And he's been using this as a template for other layout activities. So I know it looks a little bit messy right now, but we do have to turn off a couple drawings on here that are not needed. So let me do that. And we should look good now. All of the control that's around here. So control point on the wall over here, and over here, which we were able to use the direct reflect laser on our X9 laser scanner, which you can use on the X7 laser scanner as well. But we just drive the laser over to these targets on the walls, and that way whenever we scan, the scan data is positioned perfectly to the room. We were getting a 1/16 of an inch accuracy on these readings, which we were pretty happy with. So let's jump into how to actually make these 2D ramps 3D, because if I turn off the rest of this, this is all we were starting with, was this 2D drawing. So let's jump into SketchUp. We'll do a quick little tutorial on how to make these into 3D, and we'll jump back into the scan data. So now we're in SketchUp. I'm just going to make a quick model, 3D model of these 2D drawings, and we'll make a time lapse of that. But there are plenty of SketchUp tutorial videos out there. If you are interested in how to do this, then give me a shout and I can make a video on it. So jumping back into FieldLink, all we have to do is import this model into the drawing that we already have. And now we're ready to actually go in, shoot our control as we discussed before with our laser scanner. And we can do a whole bunch of comparisons and see what work has to be done. So after we run our inspection, you get a really neat heat map of the entire project compared to the model. So important to note, this was not poured, it's just an extra one in case we had some extra guys, but only 4 ramps were poured. So let's take a look at this one because it definitely stands out. Now on the left-hand side, you can see that there is a scale bar, which tells you how far away the scan is from the modeled object. So anything green is within 0.017 feet, which is a little over 3/16 of an inch. So anything in green is pretty good, and you can see anything in red here going up, you're at close to an inch off. So you can see some missing items here. It's because I turned off things that were gray or higher than an inch, but I know that this is going to be higher. And how we can see that is if I go to my model transparency, if I turn it on solid here, any data that is not showing is going to be low through the area, except for this area up here, which I know is high and above that 1 inch threshold. So if we take a look at the other ones here, you'll be able to see, let's toggle this model transparency. Everything at the top here is just a little bit low, but it is in that green shade, so we should be okay. See how it's not showing through the model whenever I solidify the transparency. Same thing down here. Let's take a peek, change our transparency. Everything is a little bit low here, so if we put back on the transparency, okay, we're getting pretty low near the bottom here, and not quite as high here. So it's just a quick little picture painting on how things look. This one here is almost all green, a little bit of blue here, but all in all looks pretty darn good. So after we paint this picture, well, I know this is high up here and low down here, I can now start to take some measurements and see if we're actually going to meet grade or not. So we will come into our ruler tool, our measuring tool at the top left, and we need to take a measurement going down here. We need to make sure that 8.3% slope is not exceeded. So if I just take a quick one right up here, let me snap to something else real quick. Right about there, down to here. We just need to take rise over run, so our z, delta z over the horizontal distance there. So with some quick math, we 9.48% slope, which is over that 8.3 threshold. Whenever we were doing this, I took these measurements live on the tablet, and I do remember getting some spots that were over 10% even. And the really neat part about this is I can now show them on this tablet, this is your high spot, and this is coming down low. So if I show them this picture, this is all high. If we can grind this down, push it down a little bit further, then we're going to be able to meet specs. So with showing them this picture, I was able to pinpoint exactly what needed done, and the apprentices then finished it off, pushed that slope down a little bit, and we'll show you a next scan after they did that work to meet compliance. So we'll turn on that scan data that we took after they fixed it. Let's turn everything else off here. Hide all except for this 17th scan. Now let's go back and do our inspection and run it one more time. So now you can see it's still a little bit high over here, but we have no gray areas. And let's just take a quick measure, go from the top here, and it is still gray, just a hair right on there. And we'll bring it down to the bottom here. Now let's do the math here, which comes out to 7.69% slope. So they're under that 8.3 threshold and everything was good. We did take measurements also from the wings here, which couldn't exceed 10 degrees of slope, which this works out to 7.7 degrees of slope. They're good there, and everything else checked out as well. So if we turn off our section box, we will check out the rest of this data. Came to find out that, in fact, these guys did also have a high spot over here, low spot over here. These wings exceeded that 10%. This wing in particular, they were able to shape that down and meet spec afterwards as well. So all in all, we didn't have to tear out the concrete while it was dried. We were able to rework it while it was wet. So we were able to make everything work out with about 10 to 15 minutes of laser scanning and data construction on all of these pours. So if you would like to look into some of this for your own company, please reach out to our local BuildingPoint representatives, and they would be happy to show you how to get your work done right, efficiently, and accurately the first time.